essentially a problem we've already solved, or at least we think we have, and that is finding volumes of revolution. But we've used a technique called the disk method, or sometimes it's called the washer method. And now we're going to look at a totally different method for doing the same job. The reason why we need two is because for certain circumstances, the disk method just doesn't work, right? The algebra that's generated by it creates integrals that are impossible to do, essentially. And so there was a need for a second method for those situations where the first one didn't work. So I'm going to show you, as my first example, how to rotate about the y-axis and things parallel to it. But we're going to start with just the y-axis. Okay, here I have a curve, and it's going to be called y equals, I'll make that 1 and I'll make that 4. So if I go 1 minus x and x minus 4, that'll work. So imagine that I'm taking this particular shape here, and I'm going to rotate it about the y-axis. And so what's the formula that would generate the volume of revolution? Now, if you can imagine that shape being rotated about the y-axis, it would be a really, oh God, what would it look like? It would look like a funny shaped donut, I guess. Like somebody took a donut, but like cut it in half and only used the top half. Some weird shape.
It would look
like
kind of like a bundt cake, you know? Look like a little bundt cake pan.
Oh,
Yeah,
well done.
exactly.
Not being a baker, the minute you said it, my wife is, yes, I like that.
Also
I guess.
a bagel.
Okay, let's move on now before we get more shapes to it. The formula for getting this shape is the integral from a to b, where a is the start value of x and b is the finish, 2 pi, a guy that's going to be called the radius, another guy that's going to be called the height, and dx. And that's the first change. Have you noticed that I'm rotating about the y-axis, but all the information is in terms of x's? Isn't that the exact opposite of the disk method? Which is kind of annoying because it means that you have to keep them very, very separate in your brain. Otherwise, the two methods kind of merge in your brain and they make some weird, horrible Frankenstein method that works none of the time. So if you rotate about the y-axis, it's 2 pi what they call the radius and the height. So let's show you what you do to calculate the radius. You pick a random spot inside the shape at position x. Because right, that's x equals 1, 2, 3, 4, 5, 6 at x. The distance that we call the radius is the distance from that rectangle to the axis of rotation. So in this case, we're going to go from x equals 1 to 4. I'm going to suck out that 2 pi out the road. And the radius is basically just x. And the height is the height of that rectangle. Isn't the height of that rectangle just f of x? Would you agree? The top of that rectangle is where it meets the curve, and the y equals f of x is that value. So this means that we now have 2 pi, the integral from 1 to 4 x times this mess. This mess happens to be, oh yeah, depends how you want to do it. It's negative x squared plus 4 plus 3x minus 4 dx. I've just FOILed that thing out to make a quadratic. So continuing, the volume then is 2 pi, the integral from 1 to 4. If you distribute the x's, you now have this guy, minus 4. And at that point, I'm just going to go dot, dot, dot. Would you agree that's just a power rule with some really ugly values? And you're finished. So if you want to rotate an object about the y-axis, then the formula you're going to use is 2 pi radius height dx. And make sure that everything that you deal with is in terms of x's. Let me find another one. Yeah, I got a list here from the previous class that I can use. So this is similar to question 9. We're going to be doing so this is what the question says. And we're going to rotate this particular object.
Is that 14x?
Yes. Let's check that. Is it 14x? I might have misread it. My writing. 45? What's that? 14x? Yeah, 14. So what we need to do here is we need to look at what this shape is. It's going to be y equals 0, which is just basically saying the x-axis. And we're going to rotate it about the y-axis. I'm pretty sure actually I know what it looks like. It looks like that. But can you put that into your Desmos or whatever and sketch it? Well, actually, you could do it in your calculator. It does cross the x-axis at 2 important places. And the reason we need to know that is because that's going to be my A and my B, right? And this is going to be the region. So let's see if I can figure out what those are. They're going to be 9 and 5. So that's going to be 5 and that's going to be 9. So here is the shape that is to be rotated about the y-axis. There's my typical rectangle at position X. So the volume is from 5 to 9. 2 pi, the radius, just X, and the height is this guy. And can we just basically say that question's over with? The height is that distance there. And the height in this case is just the value of the function. And this represents the radius. If I cut too many corners there, do you need to see what the next line is before I do dot, dot, dot? Are you comfortable how this is pretty much ready to be finished? What would I need to do before I start doing power rules?
Distribute the x.
So you're going to be doing a negative this 14x squared to that and a minus 45x. I mean, yeah, it's going to be horrendously ugly fractions. But it's going to work, right? It will work. Are we good? Okay. Let's see if we can find another one. Got all these notes, but they're all jumbled up, unfortunately. So I want to focus on just one axis at a time. Ah, okay. Here we go. Oh, nope. I'll do that one later. That's a different axis. X-axis, x-axis, x-axis. All x-axes. I can't find a y-axis to save my... Oh, here's one. It was 7. Y equals 11x, take away x squared. The line y equals 28. It's about the line x equals 4. Well, it might not look like a y-axis, but it is. It's going to be parallel to it. So I take my picture, my shape, and I draw my guy. It looks something like this. This is 0. This is 11. And then we have a y equals 28 guy. There's y equals 28 somewhere up here probably. Let me check that. Question 7. Oh. Y equals 28 is actually here. So pretend that's not there. So I want to take this little guy here. So that was my issue. Let's see what the volume looks like. Oh. Well, don't I need to know these two numbers? We're going to rotate, oh, and we're going to rotate this fella about a line called, I'm pausing here because that doesn't look right in my brain. Let me draw a picture that is clearer in my own mind. This fella comes up and down like this. This guy is at 28. This is good. The line x equals 4 is going to be down here. And the shading is there. There's just an awful lot of bits and pieces that just are not clear in my brain. Right. So the region that's being rotated is this fella. The axis of rotation is this line called x equals 4. So we are going to have to set up our integral as the integral from a start to finish, which is this number, from here to here, call it a to b, 2 pi radius height dx. Okay, so where are we off to? Well, first things first, I need to know these two numbers. So as a side issue, I need to find out where the curve, which is this guy, meets up with the straight line y equals 28. How am I going to solve that problem?
Set them equal to each other?
Yeah. So I'm going to take 28 equals 11x, take away x squared. If you add an x squared to both sides and you subtract the 11x from both sides, you get this. You get this, and that gets me 7, and that gets me 4. And of course, if I had planned this darn thing better, do you notice that my x equals 4 is now in the wrong place? This is why I probably should have a whiteboard, because couldn't I just go rub it out and then move it? I am not going to do picture number 3. I'm just going to make a mess of the picture I've got and draw the line right there. Right? So this line isn't here anymore. This is our axis of rotation. So I can go from 4 to, I've lost the guy. Oh, 47.
Mr. Albertson, just to be clear, we're not rotating this about the y-axis. We're rotating this about x equals 4, right?
We are rotating about the line x equals 4, yes.
Okay, gotcha.
And the line x equals 4 is parallel to the y-axis, but it's not the y-axis.
Aye.
Right. So 2 pi, radius, height, dx. Okay, here's my little rectangle. My little rectangle is position x. Now the radius is going to be the distance from the rectangle to the axis of rotation. So it's basically that distance there. And the height is going to be the height of this rectangle. So let's see what the radius is. If you go from here to here, that's x. If you go from here to here, that's 4. Won't the radius be the difference between those two? X take away 4. Are you happy about the distance from here to that axis of rotation is x minus 4? Now the height, well, that's 28, and the top bit is 11x take away x squared. So isn't the height the difference between the top and the bottom? And the top is 11x take away x squared minus the bottom, which is that. So we are looking for the integral from 47 of 2 pi, and now you're going to have to multiply out all of this. I'll take it one more stage. It's a bit like foiling, but instead of 2 by 2, it's a 2 by 3. But the way that you typically do this is you go x times each of these 3, and then -4 times each of these 3. So let's see what we get. We get 11x squared minus an x cubed, take away 28x. Then you have a -44x, a plus 4x squared, and you finish with a -3212, I believe.
Wouldn't the 112 be positive because it's a negative times negative?
Thank you. And this fella here is going to be a -x cubed. 11 and a 4 gets me 15x squared. And -28 and this -44 is 72. And last but not least, I believe we have 112. Okay, dot, dot, dot now. Would you agree that's just one horrendously big, ugly power rule? So do not expect 4 pi as your answer. You know, 119, 211 pi's and things like that are probably more realistic. Are we good with this question? I think if I hadn't tried to rush it, I probably would have got it done quicker. What I should have simply done is just go into Desmos and draw the damn thing, rather than me trying to imagine in my brain where it was, because I was just getting my scales all wrong, you know, locations of things.
My Zoom, there's something wrong with my Zoom. I can see you, but I can't see anything else.
Is that what everyone else has experienced, or is it just him? Are you, the rest of you seeing the...
page.
I see the paper.
Okay. Okay,
I
so we're
restarted your
good.
Zoom, I guess.
Yeah, it must be just a one-off issue then. Are we good now?
Yep.
Okay, so I think it's about time we showed you the opposite rotation. So let's look at how you find the volume when you are not rotating about the x-axis, but you rotate, sorry, y-axis, but you rotate, say something about the x-axis. Well, the first thing to notice is that the formula is very similar, isn't it? 2 pi radius height. The radius is the distance from the rectangle to the axis of rotation. And the height is how long the rectangle is. When you rotate something about the x-axis, do you notice that everything is in terms of y? So when you rotate on the y-axis direction, everything is x's. When you rotate on the x-axis direction, everything is y's. Isn't that the exact opposite of what the disk method does? When you rotate something in the x-axis with the disk method, everything is in x's, for instance. Okay. So far, so good. I haven't done much except write the formula down, but I hopefully will make that a little bit nicer in a few seconds. Okay, start with this one. Taking the curve xy equals 9, x equals 0, y equals 9, y equals 11, and we're going to rotate it about the x-axis. If you do the line xy equals 9, do you know if you rearrange it, it's 9 over x, so it looks like that. If you do x equals 9 and or y equals 9011, you get 9 and you get 11, and x equals 0 gets you this. So basically, that's the shape that is going to be rotated about the x-axis. So this information here basically allows you to figure out what the shape that's being rotated is, and then the x-axis then kicks in. Looks like that. So we are going to get the volume, the integral from c to d, 2 pi, the radius, and the height. But now, everything is going to be...
That equation to x equals 9 over y?
Yes, we will have to. Yes.
Okay, because you did
Well, I just
y
did that
equals
so I
9
could...
over x.
Yeah, I just did that so I could draw it quickly.
Okay.
Right. But you're right, I will have to do that. Now, when you rotate it this way, it's going to look like that, isn't it? Now, I can see some of the numbers. Doesn't y go from 9 to 11? So that's the limits of integration. Right. Now, I have to do one of my little rectangles. Is my rectangle going to be vertical or is my rectangle going to be horizontal? What direction do you draw it in these questions?
Horizontal.
Yeah. Now that particular rectangle is at position Y. And its radius is the distance from here to here. And that makes its radius Y. So far, so good. Now the height. Well, the height is the distance from here to here. Well, isn't that basically just the value of the function? Which brings me to 9 over y. This position here is position x, right? Think of that as x comma y. But this position isn't any use as an x, because don't I need to do the height in terms of y? So I rearrange this guy. Those three things are actually the same thing, right? Just different ways of saying them. So I now have, and our integral becomes radius times height dy. And this is not going to happen very often, but it's really cool when it does. Don't the y's cancel that? And so we're pretty much finished with that question, aren't we? Won't that just get you 9y evaluated and then times 2 pi when you're finished? Any questions about this one rotating in the x-axis? Last chance, any questions? We good? How about this one then? Taking this fella, this line, I'm going to rotate it about the x-axis. So I am not going to risk 3 versions. I am going to go and use Desmos. I have learnt from my mistakes. So if you can just hold with me for a few moments. You should have Desmos coming up. So I'm going to type that information shortly into Desmos. First, I'll have to get you to see what I can see. Where are you? Here we are. Right. Hopefully you're looking at Desmos. Right. So the first fella I'm going to type in is the x equals. So here we go. X equals 3 plus in brackets y subtract 6 close brackets, and I should be able to do squared. Right, boom. Right, a bit hard to see, so if I bring it over a bit, can you see it now? Keep that one for Andy. I also need to put x equals 12 in this. And so the region that we're going to rotate is this piece here, right? It's where the red and the blue intersect. Are we comfortable with that? Now, if we're going to do this, don't we need a start value and a finish value? Now, and we're talking about y's here, so if I look really carefully, isn't that dot, at 12,3, isn't that dot got a y coordinate of 3? And doesn't this fella have a y coordinate of 9? So although you can't see it yet, when you come in a few moments and you look at what I'm drawing, you should get to see that. 3, 9, got a guy there, got a guy there. And let's return then. I have somebody in chat. They have a question. Well, thank you for sharing your need for food. Here we go. And here we go. So we're interested in this region being rotated, right, about the x-axis. Well, we've got a lot of the setup already done for us. It's going to be the integral from y is 3 to 9. They're going to be a 2 pi, a radius, and a height. Now, if I draw my little rectangle guy, which is this fella here, would you agree that this guy is position y, and the distance from there to the ground is what we call the radius, and so the radius is y. In fact, if you're rotating about the x-axis, won't the radius always be y? Now, the height is a little bit messier. This line here is x equals 12, and this curve is that. And I want to know the distance between here and here. Won't that be 12 take away the curve? And so we're going to have from 3 to 9, 2 pi y, 12, take away the curve. Why did I stick a big bracket around all of that? What was the significance of doing that?
The negative has to be distributed through both those terms?
Yes.
All 3 terms.
So it's just to make sure that you do that. The mistake that's so easy to do, isn't it 12 take away 3, add that. You forget to distribute it. Now, if you're not the kind of person who's going to make that mistake, then that line's probably redundant. But here goes, it's y, it's going to be 9, take away y, take away 6 squared dy. And now I'm going to do a dot, 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 even though it's not finished. Won't you FOIL that out? Then subtract it from 9. Then multiply it all by y. And won't you just have a big, ugly polynomial in y's that you use a power rule on? So it is pretty much finished, isn't it, when you reach that point?
I do have a question about it.
Yes, go for it.
Could you explain again why it's the 12 minus the function?
Yeah. I want to know the distance from here to here, right? So basically, I find that distance, which is 12, and then I take away that distance, which is essentially the x coordinate, and that gets me the height. 12 take away x, but I don't use x. I use what x is equal to in terms of y. So that's the 12 take away what x is in terms of y.
Okay.
Right, if you imagine this point here, this is just happens to be at the peak. Isn't that point there the x coordinate of that point? Isn't that distance anyway, the x coordinate of that point? And
Yeah.
isn't this distance that distance, so it's a 12?
Okay. Okay, cool.
I think we have another one coming up. Here's another one. Again, it's about the x-axis. Oh, I'll risk it. That's this guy. Are we good as far as that particular one, I think it might curve more this way than that way, but that's cosmetic. This fella is pretty close to being everything we need. I know I'm going to need this thing called the radius and the height. When I'm doing this particular one, won't my rectangle look like this? So let's see what we have for this particular guy. This fella is y, and this fella is x, right? Right on the curve, x comma y. The radius is the distance from here to here, and that's going to be y. And the distance from here to here, which is going to be the height. And isn't the height just the x coordinate? This time it's the x, that whole distance, isn't that just the x coordinate? I don't need to subtract. But the x coordinate is not really what I want. Don't I want the x in terms of y? So I have to take this fella and I have to figure out what x is as a function of y. So here's your question. If y is x to the power of 3/2, what's x? Y to the power of what fraction?
2/3.
Are you all happy about that? 2/3. So, right, the volume then is going to be from 0 to 8, 2 pi, the radius, the height. The radius is y, the height is 2/3. And then just probably one more line should do it. What did I just do there? How did I get from here to here?
You multiplied y by y to the 2/3 power.
And so I just added the powers together and got 5/3. Yeah.
Yep.
And the reason I did that is so I could use a power rule, right? So it's going to be an ugly fraction, but can I do a dot, dot, dot now? So far, so good. Are you still with me? Because there's a lot to take in here, and you probably are. I'm sure you're going to have to, when you do your homework, you're going to have to pause and fight your way through the stages. But the stages are there. Draw the picture, find the radius and height, plug them into the formula, do what algebra you need, and then solve. So we have time for one last question. Let's try this one. Well, let's see if I can sketch it without too much going on. That's a little bit hard to draw, but can you trust me, it looks something like this. Well, actually, it goes down here as well. But since y is greater than or equal to and x equals 5, do you see that the region that we're going to rotate is just this piece here? It's going to be rotated, not about the line, the x-axis, but about a line called y equals 2. And y equals 2 is parallel to the x-axis. It's up here. That's y equals 2 is up here. That's the axis of rotation. Now, I need to know this guy's y coordinate. I know this guy is 0. But don't I need to know this finishing point? So don't I need to find out what the y coordinate when you plug 5 in here? Can you trust me that it's 1? And the way that I got that was simply by using this fella and saying if x is 5, solve for y. So I plugged 5 in here for x, and I found out that the y value that it happens as is 1, and another one down here I don't care about at -1. So we got this guy. We know it's going to be 2 pi, the radius, the height, dy. Right, here is my radius guy. This is my rectangle. The radius is going to be the distance from the rectangle to the axis of rotation. That's the radius. And the height is going to be from here to here. Once we've sorted those two out, this question's finished. But that's not going to be easy, but we can do it. Normally, isn't the radius just y? Because that's what happens when you rotate about the x-axis. But what happens when you rotate about a line that's parallel to it, like y = 2? Then you do have to do a bit of work. That distance is the radius, right? From the rectangle to the axis of rotation. That's what we call the radius. To find what that is, would you agree that from there to there is 2? And then from here to here is y. So putting those two together, what's the radius?
2 minus y.
So the radius is y if it's rotated about the x-axis, but if you use a line that's parallel to it, the radius is going to be 2 take away y, 2 add y, things like that. Now, let's do the height. Well, isn't the height from here to here, basically? So the height is 5 take away x, but I don't want x's. Don't I want to replace the x's with 5y squared? So there's my height. So it's the integral from 0 to 1, 2 pi, a radius of 2 take away y, and a height of 5 take away 5y squared dy. Would you agree that's pretty much the finish of that question? The rest is FOIL it out and power rules. Okay, do you want to say hi for attendance? While that's happening, I'll get myself set up. Is there any other questions, or are we good? Is that because you've too many questions to ask, or is that because you feel pretty comfortable about what you've done so far? I hope it's the latter, but that's it. Right, so tomorrow we're going to finish these guys off by doing some more examples of rotating about the x and or y. And then we move on to, well, we have 2 more sections to get done by the end of the week. So we'll move on to, average value of a function and work. I think I might do average value of function first, slightly out of sync, but that's an easier one to do. And that way I'll be able to, I'll know how much time I have left to do the final one, which is more difficult, which is the work one, in my opinion anyway. Well, that is us for today.